and that's really how we work. So it's simple enough, when you have this solution. When you have a problem, so it can be really hard to debug. We remember some cases, obviously it's just very, very complicated. And you have some restrictions. Here, for example, I do some, so not here, but you have something very similar here, where basically period is defined using itself. So you have some kind of recursion. And you cannot do that in a real order. So, for example, if you can say, okay, actually I can say period is 2 periods followed by 1 period, but actually it won't work because the way the combinator library is written in Scala, the backtracking won't work in that case, and you will just explode the stack very easily. And there is no way for Scala to know that. To do the type won't be able to detect that at the compilation time. So this is a common problem with combinators.
And I think in that case you can give up and use the packrat parsers, which will work for the most part.
Yeah, sometimes you cannot do that.
Well, the left
some grammars actually you really you can. There are actually some classes of grammars that you can't express using combinators. That's possible. And actually, Scala comes with other constructs. So, you have this parser is followed by another one. You can also say this parser is actually repeated, several times with some kind of separator. So that's really awesome because in a very few constructs you can define very easily, a lot of languages.
Rep one step.
Yeah, the rep set. So I can say, for example, so if I knew that actually the period was just a repetition of things, I was able to say web set of period, comma, and plus, and automatically I have a new parser doing the repetition for me. And in the type, I would have a list, and then I do whatever I want with that. The problem is it can be empty, and I don't want to deal with that right now. So it doesn't make any sense in that case.
There's a repsep1 that will require it to be a non-empty list.
You can do that?
Yeah, repsep1 is a separate combinator there.
Ah, okay. So we could do that. You don't do that one. Basically, you are able to parse that, and that's it. You can do that. So I have some time, so I would like to speak about something I would like to say discover, maybe it's too much. So we had some problems in our DSL library that we were doing at W3. Basically, we have an abstraction for RDF, which is just a set of triples, subject, predicate, object, and you have some notion of graphs. And this is basic. You only deal with that. And we have a simple implementation using case classes and stuff like that. And this is really a nice abstraction. Case classes should be part of. If you use Scala, I believe it will be part of most of the DSL that you will define in Scala. The problem is when you use your case classes, you are dealing with a concrete implementation all the time. And there is nothing helping you saying, okay, I would like to be able to construct, I would like to be able to deconstruct, and actually the real implementation is just hidden. We need that just to say, oh, instead of using case classes, maybe you can use just this very famous Java library to do semantic web, and just use the other stuff that we got. So you can see this problem there. So this is what I would like to say. I ended up with that. So if you have some remarks for that, I would be very interested. So basically, I would like to say, okay, for example, in this example, I have an event, and this event will start sometime, and there will be a train. In that case, I don't want to expose the date itself. I just would like to say, okay, a date is just something that goes back and forth between a triple of ints for year, month, and day, and the actual date. And so you give me an implementation, and you give me something that can so I can go back and forth between them. So I can use it, and then because I can go back and forth, I should be able to deconstruct a date and extract the year, the month, and the day from this date, for example. So this complies. There is no problem with that. So the only thing is I have to provide a type, and I have to provide a way to go back and forth. So maybe you just want to see the isomorphic stuff. So it's a bit complicated. So here we are interested in this one. So we have the first problem in Scala. When you define an object you define a case class, automatically you have an object with the apply and apply method. So this is just a way to inject and to extract stuff. And this is already there. But, so you know that you can apply because the object will have the right type for that. This is a function of something, but you don't have an apply. Maybe I'm wrong, but I couldn't find any type saying I can unapply. And actually this is a bit weird, but if you look into the parser, how they deal with that, this is a specific case.
Mm-hmm.
That's anyway. So this is actually the pattern. Runar mentioned that very quickly. The fact that you can do pattern matching is actually done using that.
Yep.
I give you an object, and I will try to do something with it,
mm-hmm.
and optionally, I can give you this triple. So in my case, it was int and a date.
So why do you have like the pattern matching 1, 2, 3 with the 3 different arguments rather than take one argument that is the triple of T1, T2, T3?
Oh, because I believe this is done this way in function.
Yes, but you're returning an option of a triple, not a. So if you said just pattern matching and took one T and one R, then you unapply and you give back an option T. Then where you're currently giving back a triple, you'd make pattern matching and you pass it a triple as the first argument, and you pass it an R as the second, and then pattern matching would work for any number of tuples or other cases.
This is the first simplification.
Yeah, that was just
But at the end, I will still need to do that. I will still need to define the isomorphic.
Yes, isomorphic 3 would still be T1, T2,
T3.
T3. Yes.
I think this is right. So I'm not sure that Scala will infer all the time the right types.
It will in that case. It's just in function 3 you're gonna have you would leave function 3 there, but pattern matching would become one constructor rather than repeating the idiom over and over again.
Okay. So thank you for that. So this is unfortunate in a way because when I define a case class, so this is for example one refinement for the type just over there. I say just by doing that, by defining a case class, I have both the type date and because of the object that will be generated, I have this stuff. But Scala doesn't know about the isomorphic stuff, so I just have to annotate that. And the funny stuff is I don't have to provide any implementation. It's already there, so of course it will compile and it will type just right away. So this is just a dumb implementation, but actually I can reuse what we defined earlier. So I can say, okay, my type date is actually the date that we defined, the one relying on the geodata implementation, and then I say, oh, I still want this isomorphic stuff. Right? Okay. So in this case, I'm just saying I had to provide the apply and apply method. The first one, this is easy. I will just rely on the one from the date. But this unapply doesn't work in that case because basically you can just extract the geodata stuff. So I just define another object for this stuff. I could just define that there. And this is this is this one. So I'm just saying, okay, if you give me a date, so it will be easy for me to just extract that stuff. I'll just get the year, the month, and the date, and this compile. So this is an easy way for you. So this is how you can just, do some composition with your implementations. One, we just use this abstraction. You just want to be able to construct and to deconstruct, and then you can just change the implementation. You just have to provide the right type and the right object to the injection and the rest. It's a bit verbose, and this is also because Scala doesn't help you for that. And so this is something that I would like to ask the Scala team, because we really need that. And actually, I've just redefined an entire abstract syntax tree using that kind of technique, and it's a bit painful. And we have other problems. So doing that, you can actually you can deal with when you have a seed trait and case classes. So you can express that kind of constraint in the abstraction. The problem is you lose something very important, which is the exhaustive pattern matching. And again, I try to hack into the compiler, and this information is not exposed as a type. This is done very specifically for pattern matching. There is just a specific object with a flag saying this is exhaustive, and of course when you use a type, this is very different because this is not an implementation. So